Solve the following system of equations algebraically. This system involves an absolute value equation and a quadratic equation. Here, we will substitute the expression for y from one equation in place of y in the other equation. This will result in an absolute value equation involving only x. We'll solve that resulting absolute value equation by separating it into two cases and solving the equation for each case, making sure we remember to reject any extraneous solutions. We'll then substitute the known values for x into either equation and solve it to determine y. From the first equation, y equals the absolute value of x plus 3. From the second, y equals negative x squared minus 4x plus 3. We can then make these expressions for x equal to each other. This results then in an absolute value equation involving a quadratic. Here we break it up into two cases. For the first case, the expression inside the absolute value, x plus 3, is greater than or equal to 0. This corresponds to x greater than or equal to negative 3. For this case, we can remove the absolute value symbols and just leave it as x plus 3. We then solve this resulting quadratic equation. To do this, I will move everything over to the left side by adding x squared, adding 4x, and subtracting 3 from both sides, giving me x squared plus 5x equals 0. Factoring out the x, we get x times x plus 5 equals 0, giving us our x values of negative 5 and 0. We have to check if either one of these are extraneous. For this case, the x must be greater than or equal to negative 3. 0 is greater than or equal to negative 3, but negative 5 is not. So we must reject this solution. We then move on to case 2. For case 2, x plus 3 is less than 0, corresponding to x less than negative 3. For this case, we have to take negative of x plus 3. Since the x plus 3 is negative, taking negative of that negative would make it positive. We then get another quadratic equation. In this case, moving everything over to the left, we end up with x squared plus 3x minus 6 equals 0. This time, the expression on the left does not factor, so I'll use the quadratic formula. Substitution gives x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 6, all divided by 2 times 1. This gives two results: negative 3 minus root 33 over 2, and negative 3 plus root 33 over 2. The first one, to 3 decimal places, is negative 4.372. The second one, 1.372. Note that the x for this case must have been less than negative 3. The first one is, in fact, less than negative 3, so it's a good solution. The second one, however, is not, so we have to ignore that solution. We then have two solutions for x. Each one of them we must substitute into one of the equations to determine y. I'll use the absolute value equation. Y equals the absolute value of x plus 3. Substituting x equals 0, we get a y value of 3. For the second x value, negative 3 minus root 33 over 2, plus 3 inside the absolute value, To simplify this, we'll get a common denominator of 2. So we'll rewrite 3 as 6 over 2. We can then combine the numerators, giving y equals the absolute value of 3 minus root 33 over 2. Note that this expression inside the absolute value would be negative. We then have to change the sign to positive, giving us y equals root 33 minus 3 divided by 2. We then have two solutions for this system. The first one, 0, 3, and the second one, negative 3 minus root 33 over 2, comma, root 33 minus 3 over 2.